Hi class, today we are going to use the law of cosines to solve oblique triangles when given the SSS case, so side, 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 or SAS, side, angle, side. And we're also going to use an area formula to solve these. So the law of cosines is given here, where the little letters represent the sides, and then the big letter is the angle. So as long as you have 2 out of the 3, you can use it. So if you have 2 sides and an angle, or 3 sides, you can use it to find the angle. So our goal is to find the largest angle first, and then switch to the law of sines if possible. So for example 1, we're going to determine whether law of sines or law of cosines is needed to solve each of these triangles. So what we want to do is we want to take the 2 angles, so it would be angle A and angle B, and then side C. And so side C would be this one. So here we're given an angle, and then a side, and then an angle. So when we're given an angle, side, angle, we're going to use law of sines. So the next one, we're given angle A, which is 26 degrees, side B, and then angle B, which is 105, which is this one. So this is angle, angle, side. And when we're given angle, angle, side, we're going to use the law of sines. Angle, angle, side. So we're going to use the law of sines. Same thing. The last one, we're given angle A is 24, side B is 16, and side C is 29. And we're given a side, an angle, and then a side. So when we're given side, angle, side, we're going to use the law of cosines. And when we use the law of cosines, we're going to use those formulas. So let's go on to the next slide. So example 2 says solve the triangle given these 3 sides. So I'm going to set up my triangle A with little a being 31. I'm going to put B over here with little b being 52. And then side C, or angle C, with side C being 28. So since I have side, 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 I'm going to use the law of cosines. And I want to find the largest angle first, and that's going to be angle B. And I know that it's angle B because angle B, even though this triangle, which is not drawn to scale, the largest side is going to be opposite the largest angle, and the smallest side is going to be opposite the smallest angle. So I'm going to go ahead and find B first. So since I want to find angle B first, I'm going to use the middle law of cosines that says that b squared is a squared plus c squared minus 2ac cosine of b. So I can plug in my a, b, and c and then find b, my angle b. So b is 52, so 52 squared is a squared, 31 squared, plus c squared, 28 squared, minus 2 times a, 31, times c, 28, cosine of angle B. So I'm just going to plug all this into my calculator and solve. So ultimately, I want to subtract those 2 to the other side. So I'm going to get 52 squared minus 31 squared minus 28 squared is negative 2 times 31 times 28 cosine of B. And so when I do that, I want to isolate my cosine of B. So I'm going to divide by this number here, which is negative 2 times 31 times 28. I'm going to do that on both sides. Negative 2 times 31 times 28. And that is going to equal cosine of B. And this whole thing I can enter directly into my calculator. And I want to make sure that you can enter it into your calculator. So please follow along. In order to enter it directly into calculator, I want parentheses around the whole top and parentheses around the whole bottom when you're dividing it. And you should get negative 0.5524 and some stuff. So make sure you can get this exact answer. So when I want to find B, I have to do cosine inverse to get B alone. So B is going to be cosine inverse of negative 0.5524 and all that stuff. I'm just going to use whatever was left over in my calculator. And I need to make sure I'm in degree mode because I want my answer in degree. And then B is going to get 123.5 degrees and some stuff. And when I convert it to DMS, I'm going to have 123 degrees, 31 minutes, and 59.339 seconds. And that's going to be my answer for B. So now that I found angle B, I know this one. This angle, which is 123 degrees and some stuff. Once you have one angle, you can switch to the law of sines. So when I switch to the law of sines, I know that the sine of angle B over side B can equal the sine of side A, or the sine of angle A over side A. So I know that sine of A over A is the sine of B over B. And I can plug in what I know. I know little a, little b, and big B. So sine of A over its opposite side, which is 31, is the sine of B. So sine of 123 degrees, 31 minutes, 59.339 seconds, all over side B, which is 52. So doing this, I have this number in my calculator still. So I'm going to do sine of that number, and then I'm going to cross multiply. So I'm going to take that number and multiply it by 31. So 31 sine of 123 and some change. And then I'm going to multiply sine of A, and I'm going to times that by 52. 52. So I'm going to isolate A, so I'm going to divide both sides by 52. I'm going to divide both sides by 52, so those cancel off. And I have sine of A equals this number. And that number is approximately 0.4969. So I have sine of A is 0.4969 and some stuff. So in order to find A, I'm going to do sine inverse. So A is sine inverse of 0.4969 and all that stuff. And I'm just going to type that into my calculator in degree mode to get that A is 29.797 and some stuff degrees, or in DMS, A equals 29 degrees, 47 minutes, 50.45 seconds would be A. And now to find angle C, I know that the sum of A, B, and C is 180 degrees. So I can just, in my calculator, subtract these two numbers from 180 degrees and get 26 degrees, 40 minutes, and 10.211 seconds. And that's how I'm going to find C. Now, I only used law of cosines the first time to find the first angle, and then I switched to law of sines. You could, of course, choose to use law of cosines to find all three angles, and that would also be okay. Okay, for this next problem, we have the port, which is 50 miles due north of a lighthouse. So I have this triangle, and I have my port up here, and I have my lighthouse up here. And if I go due north along this line, it is 50 miles due north along that line. And the ship is 30 miles at a bearing of north 37 east from the lighthouse. So start from the lighthouse. So all bearings, we're going to start at the lighthouse, and we go from the north-south line. So I know that this vertical line is a north-south line towards the direction we're going, and I'm going to go in the northeast direction. Remember, it's northeast, southwest. So from the lighthouse towards the east direction from north, it's 37 degrees. So this is my bearing, this angle here, and that's where the ship is, up here. So the ship is northeast of the lighthouse. So at a bearing of north 37 from the lighthouse. So I know I start at the lighthouse at the north-south line and go towards the east line, and that's 36 degrees. And so the path of the ship would be this way. Okay. So and it says the ship is 30 miles at a bearing. So this length here is 30 miles. And I want to know how far is the ship from the port, which I'm going to call X. Okay, so I have side angle side. And when I have side angle side, I'm going to use the law of cosines. So to use the law of cosines, I know that this side squared, or x squared, is the sum of the two other sides squared, 50 squared plus 30 squared, minus twice those numbers not squared, 50 and 30, times cosine of the angle that's opposite this x. So opposite the x is 37 degrees. So I can plug this into my calculator directly as is. And when I plug it directly as is in degree mode, I get 1004.09347. Take the square root of it, and I get 31.69. And since it's a word problem, I'm going to want a sentence answer. So I have that the ship is 31.69 miles from port. Okay, so the last thing we're going to do is the area formula. So this is a different area formula than the one from the previous section. This is Heron's formula, and this is when we're given side, side, side. So if we're given three sides, we can use this area formula. So the area of the triangle is S times S minus A, S minus B, S minus C, where A, B, and C are the sides of the triangle, and S is the sum of the three sides divided by 2. So let's go ahead and start off by finding S. So I sum the three sides, 14 plus 17 plus 7, and I'm going to divide that by 2. So when I take those three and divide by 2, it's 38 over 2, or 19. So now I can go ahead and find the area, and the area is the square root of S, which is 19, S minus A, 19 minus 14, S minus B, 19 minus 17, and S minus C, 19 minus 7. So this is the same thing. Oops, excuse me. Okay, sorry about that. We left off with the area formula. So I'm just going to simplify these three numbers inside the parentheses. And I get the square root of 19. 19 minus 14 is 5. 19 minus 17 is 2. And 19 minus, this is 7, is 12. And when I multiply those three numbers, I get 2,280. When I take the square root of that and simplify it, this is the same thing as 4 times 570, or 2 times the square root of 570, which is approximately equal to 47.75. So it is approximately that many centimeters squared, since our units were originally centimeters. And that's how we're going to apply the area formula. Okay, well, thank you so much. Have a good night.